We are going to be starting to look at volume, but before we do that, I just wanted to point out what a prism is. So a prism is an object where two ends of it are the exact same shape. So if we look at this triangular prism, you'll notice that there is a triangle on both ends of the shape. So on this front end and on the back end. Oops. Then if we look at the square prism, or in other words a cube, there is a square on both ends, on the front end and the back end, but I mean this one you can look from different directions. If we look at this pentagonal prism, we have a pentagon on the top and on the bottom, so on two ends of it there is a pentagon, which makes it a prism. We also have a rectangular prism here where we have a rectangle on both ends, and then here's a couple more octagonal prism. There's an octagon on the top and the bottom. And finally, a hexagonal prism that has a hexagon on the top and the bottom, or on two ends of it. So what makes an object a prism is that it has the same shape on two ends of it, and then those two shapes are connected by lines at every corner. So that is a prism. So let's look at volume of prisms. So in chapter 4, we're actually going to be skipping over the getting started, and we're just going to hop right into the volume of prisms, cylinders, pyramids, and cones. So to start off, let's just say what the difference between the volume and surface area of an object is. So the volume measures the space an object occupies, whereas surface area is the area of all the surfaces of an object, or all the faces of an object. So we just stopped looking at surface area, which we were finding the area of all the faces of the object, or all the surfaces of it. Now we're going to look at the amount of space an object takes up or occupies. So starting here, we have a construction worker will fill this wooden form with concrete to create a footing for a bridge. So what they're talking about is this over here. So you can see it has four sides, so it is an octagonal shape. The base is a regular octagon, it says right there, and the form is 0.6 meters tall. So if we were to look and extend this downwards, all of these corners, it would go down 0.6 meters, and then it would create another octagon on the bottom of it, which makes this a prism. How much concrete will they need? So they're wondering how much concrete will take up this entire octagonal prism. And I'm just going to write down here the height of it. So the height is equal to 0.6 meters. That's what they give us over here. So to find the volume of any prism, you multiply the area of the base times the height of the prism. That is the formula to find the volume of any prism. So in this case, the area of the base is going to be the area of that octagon on the top of it. So this one's a little bit trickier because we don't really know how to solve for the area of an octagon straight away. So let's start by finding the area of each triangle in this base. So by each triangle, you can see that they divided this octagon up into all these triangles here. So if we can find the area of one of them, then we can multiply it by 8, since there's 8 of them, and get that full area of the base. So to start off, let's find the area of the triangle. So the area of the triangle, well, the area of any triangle, is 1/2 times the base times the height of the triangle. So for this example, they actually made it a little more tricky than I would have liked because they decided to use different units. So you'll see for the height's given to us in meters over here, whereas they gave us the measurements for everything else in centimeters. Now, whenever we're dealing with multiplying units, they need to be the same measurement or else our steps won't make any sense. So let's convert them all to meters. So if we're thinking 30 centimeters, that is going to be equal to 0.3 meters. And then this 36 centimeters up here, that's the same as 0.36 meters. So let's do all of our calculations in meters so that everything aligns properly. So finding the area of the triangle, we have 1/2 times the base times the height. So the height of the triangle is going to be 0.36 meters. And then down here, they put in that base, which is 0.3 meters, which we have going along the bottom of the triangle here. So 1/2 times 0.3 times 0.36 is equal to 0.054 meters squared. So that is the area of one triangle. So now we need to find the area of the entire base. So in order to do that, we have to take that area of the one triangle and multiply it by 8, because there's 8 triangles making up that total octagonal shape of the base. So I'm going to do 8 times 0.054 meters, or in other words, that gives us 0.432 meters squared. So now that we have the area of the base, it's super easy for us to find the volume of the entire object, or the entire prism. So what we're going to do is we're going to do the area of the base times the height. So over here, let's just put area of base. And I'm going to write it like this. So I put a big A and then a subscript base. So that means area of base times the height. So the area of the base we got up here, which is 0.432. And then the height of the entire thing we have in orange over there, 0.6. So multiply both of those together and you get 0.2592 meters. And since we're dealing with volume, volume is a three-dimensional thing, it's going to be meters cubed. So if we round this up, we are going to get 0.26 meters cubed of concrete. So remember, we have to find the area of the base and then multiply it by the height. Now I also want to point out before we move on that a cylinder is also a prism. Okay, so it is a prism, and for some reason it has a special name. So instead of calling it a circular prism, because both ends are circles, they just call it a cylinder. But cylinders would follow the exact same formula for volume as prisms do. So you would find the area of the base, and then you'd multiply it by the height of the entire cylinder, which would be this side over here. That would be the height. So moving on to the next example, I'm going to cross out a bunch of parts of this example because it requires us to do an experiment, but don't worry about it, we'll just calculate some volumes. So we're going to cross out this here. We're also going to cross out this, so part C, part D, and part E. We're going to cross out those ones, and then we're just going to do B and F. So we're going to ignore this big blurb up here, and we're just going to solve for the volume of this rectangular prism. So here we have a prism. Ignore that pyramid on the inside. We won't worry about that for this one. So it says for B, what is the volume of the prism? So remember, for any prism, we have to find the area of the base, and then we're going to multiply that times the height. So let's look at the area of the base of this prism. So the base is what it's sitting on here. So that shape looks to be a square because they measured this side of it here, and it does say it is a square-based prism. So I'm going to also put 6.0 on this side. So the area of that base would be length times width, which is equal to 6 times 6, which is equal to 36. So we're going to put 36 as the area of the base. Then for the height of it is this one here, so it'll be 8.5 centimeters. So in other words, if we did 36 times 8.5 centimeters, we get 306 centimeters cubed. Sorry, I put a dot there. So 306 centimeters cubed as the volume of the prism. So we did the area of the base times the height. So in our calculator, if we do 36 times 8.5, we get the volume is 306 centimeters cubed. So in our calculators, we're going to do 36 times 8.5, and in total we get 306 centimeters cubed for the volume of that square-based prism. Now remember, the volume of a prism is always going to be the area of the base times the height. But now let's look at the volume of a pyramid or of a cone formula. So both of these are going to be the same. So pyramid or volume of a cone. So a pyramid and a cone are very similar shapes. When we're dealing with cones, it has a circular bottom, and then that circle all reaches up to one point like that. If we're dealing with a pyramid, it's the exact same idea, except this bottom shape can be any other shape other than a circle. So for instance, it could be a rectangle or a square, but then all the corners reach up to a common point. It could also be a triangular-based pyramid. These are kind of hard to draw, but something like that. It could also have a octagon or pentagon on the bottom of it, and so on. So pyramids can have different size bases or different shape bases, but the formula will be the same for all of them. So the formula for the volume of a pyramid or the volume of a cone is the area of the base times the height divided by 3. So this line here means divided by. So it's a very similar formula to the volume of a prism, but this time we are dividing by 3. So let's look at example 2. Monique is an artisan who makes bracelets. To size the bracelet, she needs to make a solid cone mandrel. The cone has a radius of 2 inches and a height of 10 inches. What is the volume of the mandrel to the nearest cubic inch? So the volume of a cone, just like I set up here, is going to be the area of the base times the height divided by 3. So the base shape when we're dealing with a cone is a circle. So base is a circle. So we need to find the area of the circle, times it by the height, and then divide it by 3. So the area of the circle is going to equal pi r squared. Pi r squared is the area of a circle. So over here in our formula, we're going to put the volume is pi times the radius squared, so you'll notice this part's squared, and the radius they give us is 2. So pi times 2 squared. Then the height of the cone we are given is 10. So we're going to multiply all of that by 10, and then we're going to divide by 3. So in your calculator, you're going to put pi times 2 squared times 10 divided by 3. So if you plug that into your calculator correctly, you should get that the volume is 41.887 inches cubed, or cubic inches. That's what this says here. So inches cubed. So the volume of the mandrel is, let's round this to 42 inches cubed. So in the practice questions, they gave you a bunch of prisms to find the volume of, and then a bunch of pyramids or cones. So these first 3 are all prisms. And in order to find the volume, you're going to do area of the base times the height. And then in these second practice problems, these are all cones or pyramids. So your volume formula is area of the base times the height divided by 3.